Hello, class. I wanted to go over the week 7 formative assessment. And so you go to your modules and you pull up the week 7 and you have your formative assessment. And so we click on that. All right. And so it gives you basic instructions like you've seen before. And you can view your assessment instructions here, or you can click on this to download it. So I'm going to download it just so that I can bring it up a little bit bigger. All right, so we're going to make it bigger. Enable editing just so I can view it. And I like to view it one page at a time. All right, so we are going through this assessment. And for this assessment, we are looking at gas properties. And so you are going to do a simulation. And so you can hit Control and then click the link, and the FET simulation is going to come up. All right, and so we're going to go back to the assignment so we can figure out what we're going to do. Okay, because it tells you in the assignment. So the week 7 formative assessment has two parts. The first part has to do with the gas laws. The second with the kinetic molecular theory, and you will be using the FET simulator found in this link. Okay, so if we're looking at part 1, we're dealing with the gas laws. And so you want to predict what you will find and then use the FET simulator to confirm your thinking. All right, and so this is the volume pressure, and you want to see what relationship does volume have with pressure. Okay, and so you're going to draw what you think this graph should look like. All right, and then you're going to explain what you thought. All right, and then you're going to do it for volume temperature, for temperature pressure. Okay, so the boxes don't always correlate, but anyway, this graph goes with temperature pressure, and then the number of particles in volume. All right, and so then you're going to do the experiment. Okay, this is what you're using the FET simulator to do. Okay, for each of these, though, make sure that you not only draw your line in the graph, so you want to see if the graph is increasing or decreasing, if it's constant, all those kind of things. And then you want to explain, okay, what happens as the volume increases, what happens to the temperature is basically what you're explaining here. So make sure that you do the graph and the explanation for full credit. Very important. And so you're going to write, okay, so for each case, you're going to write a short description of how to use the sim to collect data. Okay, this is simulator. Then you make an Excel spreadsheet for each graph and curve fit some helpful hints. If you set a parameter like temperature constant, then make a change. You may have to watch the temperature adjust and not record the data until the temperature is back to the original setting. These experiments would be difficult in a real situation because it's complicated to isolate parameters like you can in the simulation. So let's look at the simulation. All right, so we're on the ideal gas simulator. All right, so if we're looking at this, so you have different things that you can adjust. You can look at the pressure, you can adjust the temperature, you can adjust it here as well. These are your particles, and so this is what, gets your particles in there. Or you can change this number, okay, to input your particles. You could change the different types of particles that you add. Okay, so that changes your particles. So kind of play around with it. This is what holds things constant. So if you want to hold volume constant or temperature or pressure, all right, so that changes different things. And so you can look at the collision calculator, the stopwatch. You can measure the width. Okay, so all of these things you can play around with. So play around with this. You can stop it, okay, and then start it up again slowly, or you can just have it going at a fun pace, okay? So this tells you the pressure. So then your volume, if you keep that constant, you see that your pressure changes. If you keep temperature constant, okay, then you see those changes. If we go back to volume, you can always add more heat. You see how that affects the pressure, okay? And so you can play around with this and see what you're looking at for your parameters, but you're looking at these four cases. When it says Roman numerals 1 through 4, it's talking about these four cases you're going to do the simulation for, okay? So after you made your Excel graphs, check your predictions and see if any might need corrections. If necessary, make corrections in a different color, including corrections to your reasoning, okay? And so then you want to complete this table. Determine if it's a direct or indirect relationship between these four parameters. What are the constants? Okay, whose law is represented in these four relationships? And briefly, why according to the particle model? Okay, so you're going to fill in that table. Then you're going to answer the questions based on what you got. So then you have the kinetic molecular theory. All right, so you have this one. And so we're going to bring this one up. All right, and we are looking at, oh, that might not work. Okay, I'm going to see if that doesn't work. We may eliminate that. All right. I'm just now noticing that that link is not working. All right, so let me see if I can get this to work. Might just need a different simulation. So we're gonna look and see. Glad I'm on this video so that you'll know what's going on. So chemical equations, Beer's law, build an atom, polarity, concentration. Mm. All right, so I do not see what I want. Let me try. Hmm. Oh, all right, so gas properties. Um, Okay, so what we're going to do is, based on the questions, you can use that same simulator. Let me make sure. Okay, let me restart. Oh, this button right here, this orange button, that resets it. All right, so we're going to look back at the description. Okay, so you're going to open the gas properties, then use the pump to put a little gas into the box. Observe gas particle behavior. Pump in some lighter particles and talk about similarities and differences between heavy and lighter particles. Use a simulation to see how changing the temperature affects the behavior of the gas particles, and write a description for a gas based on your observations. Okay, so we can do that with the first simulation. So just to let you know. So you're going to use the same simulator and you are going to do these parts. So you're going to pump some lighter particles and talk about the similarities and the differences between the heavy and light. Okay, remember I showed you that. So you have your heavier particles, your light particles, and this controls how many you pump in. Okay, and then it says you're going to use a simulator to see how changing the temperature affects the behavior of the gas particles. Okay, and so I showed you that as well. So this changes the temperature, or you can put this in Celsius. Okay, so you can either make it cold or you can make it hot. Okay, so that will be changing, your temperature of that, and then you're going to write a description, okay, about that, and then answer the questions based on that. All right. And so, if you have any questions, remember you're using the same simulator for both part one and part two. Okay. So, make sure that you do that. If you have questions, though, as you're going through this, please let me know. Have an awesome day. Bye bye.